So, hey everyone, today we are going to discuss this question Q sort from round 909 div 3. I found this question very interesting, so thought let's take this question for a while. Yeah, so let's just begin. Question says Vlad found an array A of integers and decided to sort it in non decreasing order. To do this, Vlad can apply the following operation any number of times. Extract the first element of the array and insert it at the end, and swap that element with the previous one until till it becomes first or until it becomes strictly greater than previous one, right? Basically, and these both actions are part of a single operation. When you perform one operation, that means you perform both of this action exactly once, right? And this is a given example. What we have to do, like, we have to determine how much operation does he need to apply to get a sorted array, or is it even possible to make the sorted array using these steps, using these operations, right? So I'll just go and explain it. Right now, this is the example given for this. Like 1 minute. This is the example. So we can go through it. How actually the question, how does operation exactly happen? Right. I'll explain you. So we have numbers 4, 3, 1, 2, 6, 4. Basically, when we apply a single operation, this means first number of the array goes to the last position right here, and it gets swapped. Like after going here, it will get swapped until it's strictly greater. It becomes strictly greater than the previous one. That means that will get swapped until it gets greater than previous one. So this would look like this. 4 swapped with 4. This would be same as this. This is our element. Now, as this is strictly less than this, or it is not even equal to, so we will swap them, and the array will look something like this. Right. And yeah, so basically these steps all are considered in all steps here are basically a single operation, one operation. So now let's see how we can do this. As you can see, one important observation to get the idea of the whole solution would be to observe one little thing here. If you observe that thing, that means you would be halfway to the solution, right? So one thing I would say, let's extend that example, right? Basically, okay, just we had this, right? And I'll just erase this part. So we are left with this array after performing one operation, right? And what we can do now is perform the operation again until array becomes sorted. I'll do the operation on the first element again. We have performed one operation and I'm doing the operation on 3. So array would look something like this. 3 would come here at first, then it would get swapped until it's greater, it's strictly greater than previous one. So after swapping elements, it would look something like this, as 3 is strictly greater than 4. Just take a rough page and pen. You would do it by your hand. You will get clarity how this operation works, right? So after one operation, this is the case. And now is the issue, right? Now our array isn't actually sorted, unsorted. But now if we apply this operation on one would come here and array would look something like this. Okay, one has gone there. Now one would get swapped with 4, and after this it would look something like this, and then it would get swapped with 6, then it would get swapped with 4 again, and then again 3, again 2, and again 1. Like basically it would get swapped again and again, just because 1 is the minimum element of the array. 1 is minimum element in array A. So there is nothing strictly greater than 1, right? If something is minimum element in an array, then there is nothing strictly greater than, sorry, less than it. Right? There is nothing less than 1 in this array, right? So after swap, like in our question, as you can see, we swap that element with previous one until it becomes the first element, or it becomes strictly greater than the previous one. As we know from the array, 1 cannot be greater than anything, right? In this array, 1 cannot be greater than any other element. So that means कि 1 would be back in position number 1. That would mean after swapping, after performing operation again, the array would again look like something like this, right? The 1 would get swapped and swapped again and again, and it would return back to position 1 because it is the minimum element of the array and nothing is strictly less than it. Nothing is strictly less than it, so 1 would get back to the position 1. As nothing is less than it, so 1 would come back to its original position, right? Original position, that means first, like, we need something greater than 1, like, sorry, less than 1, so that it could be occupied right here, or 1 would take the position number 1. So okay, I think you get the idea. So what I'm trying to say here is, now when we perform operation again, there won't be any changes in the array, and this would be repeated infinite times, and array would be the same. What I'm trying to say here, after you encounter minimum element and take it to the first position, after that you cannot sort the array. That means once you have minimum element at position 1, that is beginning, then you cannot further sort the array, cannot further sort the array using operations. What this would mean, let's say we had an array like this and we have our minimum element here. This is minimum. The portion before minimum would get sorted. Like this would be swapped here, like here and then get swapped, and it would be it would get to its original position, like it would get to its sorted position from here. Okay. Right. Again, much better to write can be sorted using operations, and this part cannot be sorted using operations. I think this diagram makes it pretty clear. So basically, if this part of the array is not sorted, then we can perform operations on it, and after operations the array would become sorted. This part of array would become sorted, and talking about this part, this must be sorted. If like this portion of array must be sorted, or else like this cannot be sorted by using operations. So this must be sorted initially, right? So basically, because minimum element is right here, like when you perform the operation, let's say you have done with this part, right? And when you apply the operation again on here, the minimum would come here and it would get swapped and swapped and swapped again until it becomes position 1. So basically the turn for these elements never come, and you won't be able to do anything to these elements using operations, and when you apply operations, you can apply infinite operations basically, and there would be no change. So there's no use of applying operations right here. What would be right? This was the whole intuition behind the problem. If you had the idea, like you cannot further sort the element, like you cannot move further after like getting the minimum element at position 1, then this question was easy. Like once you figure out this idea, like say you have the minimum element at the least position at the beginning of array, you cannot do anything further, right? You cannot just do anything further, because this would just go to infinite. You cannot like apply infinite operations, but nothing will change. Okay. And I think that just solves our question. So basically I'll just jot down the main takeaways from our question. This would be first, can be sorted using, okay, this part of array can be sorted using operations, like the elements before, let's say there are k elements before minimum, right? There are k elements before minimum, so we would take k operations. We would require k operations to sort the array, given that this part of array is sorted. If this part of array isn't sorted, then this k operations will of course sort the array. This part will be sorted, but this would still remain unsorted. So to summarize, basically if this part is sorted earlier, and so that means we would take k operations and the array would become sorted. But if this part isn't sorted, initially, then we would just print a -1, right? So without wasting further much time, I'll just show you the code and I'll tell you how did I apply it, right? So this is my code. Okay, what I'm doing here is taking the input for test cases, and this is the size of the array, making a vector of int and taking input of the vector. Now this is minimum element iterator, right? Auto minimum element. This function of STL just gives us the minimum element iterator, and to get index from it I'm just subtracting the minimum element iterator min it minus of a dot begin, so I'll get the index, right? A dot begin is at points to 0th element, so subtracting this would give me the index. And I'm creating I'm creating a boolean check. So I'm iterating from my minimum index to the end of the array, just n minus 1, because I'll explain it. So to check if my a of I is greater than a of I plus 1, this means my element, the current element, is greater than next element, which means array is unsorted. If the array is unsorted, I am making check equal to 0, right? Okay, I'll just explain this part to get the whole idea. So this is my code. Must be visible. So basically this part checks if my array unsorted part, like this says is my array unsorted from minimum to the end, right? If this part is unsorted, we cannot do anything. So this, like, if let's say this is minimum, if this element is greater than this element, if this element is greater than this, that means it's decreasing, and that means unsorted, right? So if this is unsorted, I'm making check equal to 0, and if my check is equal to 1, which means array of that portion, that minimum and that portion is sorted, then I'll just print the minimum index. I'll just print the minimum index right here, like we have calculated the minimum index at which minimum position of the element of the array exists. And if my next that portion is unsorted, check equal to 0, I'll just print -1. That means array cannot be sorted, using operations, right? So that's it. Thank you for listening. I guess if you are hearing this video up till now, thanks a lot, and yeah, thank you. Chalo, see ya, bye.